Our new layout here is similar to the last example, except that the 4 tracks are now combined into a single track just before it enters into the station. And the sections of track here have different lengths in them compared to the last example. We can imagine that this represents a section of track somewhere on our layout. We have a start point and we have a destination station. And somewhere on the layout there is an intervening section of track that includes 4 different paths that the train could take. Now these sections of track could all be grouped together like this, but you could also imagine that these 4 sections of track are spread across different locations on your layout. But effectively they represent 4 different paths to this single path and then into the station. The train route that we're going to use has similar steps as the last train route. The only difference is that the names of the blocks in the station are different, but that makes no difference to the operation. So our train is travelling from B1 to the station using the shortest path selection option. So let's click the start button and see what happens. Well, we see that just like in the last example, it has chosen the path with the least amount of blocks in it, despite the fact that this particular path is actually the longest in terms of length of the 4 different choices it could have taken. And just like the previous example, if the route is occupied, it will then select the path that contains the next highest amount of blocks, which is the 2-block path here. If we allow the route to continue, we will see which block is selected in the station. And here we can see that it's selected this top block here. And if I stop the route and reset it and re-enable this block again, we will see that it again selects that same block in the station. This is block 13, 14, 15 and 16. If I reset the route again and this time disable this receiving block, we'll see what happens this time. And what we see is it chooses the next block down now. The block order in the station is defined by the list that we have in the train route here, which is 13, 14, 15, 16. This is determining the order of the selection in the station, and it is not the station properties order that we see here. If I change this order and move that to block 14, so we can see it's 14, 13, 15, 16. If I change that here and re-enable block 13 and reset the route, put it back into there and set it, and then press the button, we see that it still chooses block 13 because it is using the order listed in the train route rather than the list in the station properties. That is because we are using a train route and not automatic routing without a route. Now, unlike the station properties, where we can change the order of the blocks here, in the train route we cannot change the order of the blocks that are shown here. There is no move up or move down button, and we can't double click on the block names to change them. If we try to insert a block, it will just insert block 12, which is no good. And if we try to insert in the middle here, we just get a copy of B14. So with this particular track setup, we cannot influence the block that is selected in the station other than making it unavailable. But let's continue with this train route and see what happens. So we allow the train to enter into the station. It will then go through its 1 second wait period, and then it selects a route back to B1. But note which path it has chosen to go back. If we stop and start it, we see that it is consistently selecting that particular path. So why that path and not the path that had the single block in it? If we look closely, the path it is now selecting is the path with the shortest physical length and not the path with the least amount of blocks. So why is that? Well, I hinted at this earlier. We need to consider the path at each of the steps in the route. When the train is travelling from block 1 to the station, there are multiple different paths that it can choose from. And we told iTrain to use the shortest path option when it was travelling into this station. Now the train is travelling from the station to block 1, and even though there are multiple paths that it could choose from, there is only one block at the destination. Therefore, in the train route step, there is no option for choosing a selection method. iTrain therefore reverts to its standard routing algorithm, which is also confusingly described as being the shortest path, except that this time it means shortest path length. As I suggested earlier, it would be clearer if shortest path selection was called least blocks or number of blocks. Of course, if our destination was a station with multiple blocks, we would again be able to select shortest path selection on the return journey if we wished. Let's let the route complete itself and let it go back to where it is entering the station again. So it goes into B1. When it arrives at the end of B1, it performs its wait, and now it's going back in the other direction again, and we're going into the station. It has chosen the shortest path in terms of the block numbers. And if we let that go into the station, and we can see that it's chosen block 13 again. So with this example, compared to the previous example where the pass went directly into each of the blocks of the station, it is not obvious that the blocks in the station are being ordered by their path length. And if our multiple intervening paths were hidden amongst a more complex layout, it would be very easy to conclude that shortest path selection was not working, because it always selects the same block in the station, no matter what path is available in the intervening paths. So although it is not technically accurate, I like to think of shortest path selection as sorting the paths to the station rather than sorting the blocks in the station. In this way, I find it easier to predict what will happen. Maybe that is a useful way for you to also see it. So that is shortest path selection. Although it might be an option that has limited applications, it was certainly useful in helping us to gain a better understanding of other things that happen in iTrain. Over the 2 tutorials, we have learnt that shortest path selection is not a viable option to use with automatic routing without a route, but it is a viable option to use in a train route. We saw that the route needs to contain multiple available paths for it to be effective, and we saw that the shortest path selection option is unique in that the path is measured by the number of blocks in the path, and not like the normal case where the path is measured by its length. So, have you learnt anything more about shortest path that will help you find an application for it on your layout? If you have, or you are already using it on your layout, we would be very interested to hear how you are using it. To do so, make a post on the forum and attach a copy of your layout file. We would really love to see examples of how it can be used. I'll leave you with one more thing to ponder. In our example up here, it demonstrated that iTrain was selecting shortest path based on the number of blocks. If you look at the operation of this layout more closely, you will see that because of the selection of the length of the blocks, that were being used in the various paths, iTrain was also effectively sorting the paths in order of the longest length of path, from longest to the shortest. The longest path is the path with the least amount of blocks in it, and the shortest path is the block with the most amount of blocks in it. And that was just due to the lengths of blocks that I chose for each of these paths. So maybe that's a useful way of using shortest path selection, to actually sort the paths in terms of their longest to shortest length. Thanks for watching, and thank you to everyone who has given a couple of more seconds of your time to press the like button. It is really appreciated. See you next time.